Hi everybody. In this lesson we want to look at how we add rational expressions or algebraic fractions. So the key to success in learning how to do these, because many students find difficulty with these, is to learn to do the problems exactly as I show you here, and also learn to be neat and don't skip steps. Problems like these can sometimes seem cumbersome, but by taking the time to write out all the steps, you'll actually save time from making mistakes. So I want to start with an example from arithmetic that shows how we add and subtract algebraic expressions, and in particular, you'll notice that because we need to get a common denominator when we add and subtract fractions or algebraic expressions, this one right here, it's hard to see exactly what the common denominator is. And so the way that we find that is we begin by factoring the denominator. So notice that 28 is 4 times 7. I'm going to write that as 2 times 2 times 7. And I'm going to leave a little space right here next to this fraction. Again, learn to do these just like I'm showing you here. Leave a little space because I know I'm going to have to multiply it by something convenient to make the denominators the same. Now 18 is 9 times 2, so let's write that as 2 times 3 times 3. And then you want to look at these denominators, and we know that to add them we need a common denominator. Well, once you have it factored, you can see that there's two 2's over here. I got a 2 times a 2, but I only have one 2 over here. So I need another 2 in the denominator, which means I also need to multiply by 2 in the numerator, because 2 over 2 is just 1. That's not going to change the 7/18 that I have here. But it is going to give me the extra 2 that I need in the denominator. Likewise, there's a 7 over here, but I don't have any 7's over here. So I'm going to multiply by 7 over 7. And now I have two 2's and a 7 over here, and I've got two 2's and a 7 over here. And you can see that I also have two 3's in this fraction that I don't have over here. So I'm going to multiply by a 3 times a 3 there as well. Okay, so now when I compare those denominators, I've got two 2's, two 3's, and a 7, and two 2's, two 3's, and a 7. So that is my common denominator, and I didn't actually have to know what that multiplies out to become. And now when I go to complete the addition, I can see that I've got 5 times 9 right here, so that's going to be 45. And then I can combine the numerators over this common denominator over here. I've got 7 times 7 is 49. 49 times 2 is 98. And then here I've got 4 times 7 times 9. And so I think I'll go ahead and figure that out on my calculator. So 4 times 7 times 9 is 252. Okay? And then I can just combine the 45 and the 98. What's that give me? 13, and carry the 143, 250 seconds. Okay? Well, again, that illustrates the process that we want to do when we add algebraic fractions. Okay, so here I've got 5 over x plus 3 over 2x, and you want to look at these factors that you have in the denominator, and what you'll notice is that this denominator has just an x, this denominator has an x as well, but it has a 2, so I need to multiply this fraction by 2 over 2, and now I have a common denominator, and I can just put those together. I'll get 10 from this numerator plus the 3 over your common denominator 2x. So this is just 13 over 2x. Okay? Now right next to this problem I have 5 over x plus 2 plus 3 over 2 times x. And you'll notice it looks somewhat similar. I've got a 5 over x, but no, I've got an x plus 2 here and 3 over 2x. So the key here is to recognize that this whole factor, this whole x plus 2, that's a separate factor. You might want to put parentheses around it to emphasize that. And so this denominator here has an x plus 2, but over here this fraction does not have an x plus 2 in the denominator, so I need to add one in there. So I'm going to multiply by the whole quantity x plus 2. Now over on this one I've got a 2 and an x in the denominator. I don't have either of those here, so I'm going to have to multiply this one by 2x over 2x. So that gives me now a common denominator. I've got an x plus 2 in both denominators. I've got a 2 and an x in both denominators. So from there, I can take this numerator, that's going to be 10x, plus, and then I have this numerator, the 3 times the x plus 2, and that's all over my common denominator, 2x times x plus 2. Okay, so now I just need to simplify my numerator here. That's 10x plus 3x plus 6 all over the 2x times x plus 2. Now you'll notice I didn't multiply out the denominator. It's usually better to just leave that factored. Alright, so let's combine my like terms. I'm going to get 13x plus 6 all over the 2x times x plus 2. And you see that that's my answer here, very different from my answer over here to this other problem. Okay, so let's move on to the next problem there. One last problem here, 7 over, now here I have a trinomial, and many students will look and say, well, I've got a 3y squared here and a 3y squared here. Oh, but this is a y and that's a negative 2y. How am I going to make that the same? Well, that's the wrong way to go about thinking about this problem, because the 3y squared is a term and not a factor. It'd be kind of like, you know, in this original problem up here, noticing that there's an 8 in each one of these, and how can I make the 18 a 28? That won't work. Okay, you need to factor those denominators. So I'm going to go ahead and factor this first denominator. The way you factor 3y squared is going to be 3y and y. So I need to factor this as two binomials, and I need to think of the factors of 4 that would combine somehow with the 3 and the 1 to make 1 in the middle. I think if I put a 4 here and a 1 here, that'd give me a 3y and a 4y, and if I combine those just right, I'll get 1y in the middle. Okay, now I want a plus 1y, so I'm going to put the plus on the big 4y, and then I'm going to put a minus on the negative 3y right here, and you combine those, you get 1y, and notice the 4 times minus 1 does make minus 4. Now I'm going to leave a little extra room here to add in what I need to get a common denominator, and then I'll go over here and factor this other denominator. So let's factor that as 3y and y again. And the factors of 8, that would give me 2 in the middle. I'm thinking probably the inner factors 4 and 2. Let's try putting a 4 here and a 2 here, and I'm sort of led to put a 4 here because I have a 3y plus 4 over here, and there's a little psychology in these problems that sometimes you'll end up with the same factors here. So if I notice, that would give me 6y and 4y, and again, if I do that just right, I can get a negative 2y here. So if I were to put a negative with the 2, that'd make negative 6y, and a positive with a 4 plus 4y, that does give me the negative 2y in the middle, and then I get negative 8. Alright, so when I look at these two fractions now, you see I have a factor of 3y plus 4 over here. Oh, and I have a factor of 3y plus 4 over here. I have a factor of y minus 1 over here. No factor of y minus 1 over here, so I'm going to have to add that in. I'll multiply by y minus 1 over y minus 1, and I like to just put parentheses around this whole numerator just to remind myself that I have to multiply the whole y minus 1 times the whole 9y plus 2. So this is going to be a FOIL problem. Alright, so I've got everything over here is also here, and then I look over here and I got a y minus 2 that I don't have over here, so I'll have to add that in to this left fraction. Okay, so here we have it. All I have to do now, I have my common denominator. I'm going to get 7 times y minus 2 plus the 9y plus 2 times the y minus 1, and that's all over this common denominator, 3y plus 4 times y minus 1 times y minus 2. So now I just have to simplify this. Notice I'll multiply it out and I'll have some terms that will combine. So I'm going to get 7y minus 14, because I have to distribute, of course. And then here I need to FOIL this out. So that's going to be 9y squared, and that's a negative 9y, plus 2y, that's negative 7y, and then minus 2. And to save time, since it's kind of clunky to write all that out, sometimes I'll just write denominator, and then I can go below that and put in my final answer. I'm going to get, well, maybe I better check just to make sure. Let me do it over here. 9y squared. Let's see, the 7y's. Oh, that's nice. Those will cancel, won't they? 9y squared, and then I've got a minus 16 all over 3y plus 4 times y minus 1 and y minus 2. Now I was almost hoping, I thought I might be done, but then after I simplify my numerator, I notice that this can be factored. That's actually the difference of squares, and not only can you factor it, but one of those factors is going to cancel. So this is going to give me, let's factor that numerator there. That'll be 3y plus 4 times 3y minus 4. That's the difference of squares. And you see that those 3y plus 4s are going to cancel. So let's go ahead and cancel those. And again, when I cancel those, I'm actually making an assumption that y doesn't equal negative 4/3, or another way of saying is that the 3y plus 4, the whole quantity, doesn't equal 0, because then 0 over 0 really wouldn't cancel. So this is going to end up equaling 3y minus 4 over y minus 1 times y minus 2. And if I just wanted to be really exact in my answer, I would note that domain restriction that y cannot equal negative 4/3, right? Because that would make 0 over 0 there. So this would be your most correct answer for that problem.